Okay, good morning. I'll start the class. I think I waited more than 10 minutes, 5 minutes over, 7 minutes. What we discussed in the last class? Tell me first. What have we discussed in the last class? Really? Students, what we have discussed in the last class?
About environmental pollutions, ma'am.
Till where we completed? This is done? Hmm? Effects, oxides of sulfur is been done? Are you able to see the slides? Controlling measures we have done with the sulfur oxide, sulfur dioxide compounds. So sulfur dioxide, oxides of sulfur, the sources, effects and controlling measures we have seen in the last class. Next we'll see nitrogen dioxide also we completed, I guess, right? Nitrogen dioxide is a reddish brown gas and its sources, how these are produced, how oxides of nitrogen is produced in the atmosphere, and what are its effects, and what are its controlling measures also we have seen, right? Selective catalytic reduction, absorption method, and treatment of fuel gas by injection or sorbents, how it is being done. Oxides of nitrogen also is done. So now we start with the hydrocarbons. Hydrocarbons is an anthropogenic biological decay process. The main sources are anaerobic. It is an anaerobic biological decay process in nature. From this, hydrocarbons released into the atmosphere, or another way is bacterial decomposition of organic matter or sewage waste. So this organic matter contains CH2O as a methanol or methane or any organic matter which contains carbon CH2O compound, which which after bacterial decomposition it liberates carbon dioxide and methane. Methane is nothing but hydrocarbons, CH4. Methane is nothing but hydrocarbons. This are you able to see this slide?
Yes, ma'am, visible.
What is there on the slide?
Oxides of nitrogen.
No, hydrocarbons is there on the slide.
No, ma'am, it's visible, hydrocarbons.
Okay, I think slideshow is not working. Fine. Yes. So this hydrocarbons, anaerobic biological decay process in nature or automobile exhaust consist of unburnt petrol. The industrial sources include pulp industry, petroleum refineries, coke even plants, and chemical industries, etc. So these are the main sources. Main sources means one is anaerobic biological decay, bacterial decomposition, automobile exhaust, and industrial sources. How do we control this liberation of hydrocarbons? Hydrocarbons are nothing but that contains only hydrogen and carbon. So these hydrocarbons, how we can control hydrocarbon from auto exhaust can controlled by processes such as incineration, absorption method. And by incineration means heating it, burning it at high temperature. Adsorption is absorbing the one substance on the compound. Absorption is absorbing. By this way, we can have a controlled liberation of hydrocarbons. See, once these hydrocarbons are liberated, either any of this method can be converted to carbon dioxide and water using analytic converters or a catalytic converters, any catalyst or analytic converters. Methane are nothing but hydrocarbons in presence of oxygen can be converted to carbon dioxide and water. So this is one way of, one second, need to switch off your camera, need to HM. So this way we can have a control on methane and production of methane and water. So the next is particulate matter. Particulate matters are of different sizes. Any tiny particles like, but what is particulate matters? Only hydrocarbons is only this much. Hydrocarbons are what are the sources, how it liberates hydrocarbons, how we can control the hydrocarbons. Next type of air pollutant is particulate matter. Air particulate matters are very tiny size particles. They are of different sizes, structures that released into atmosphere, which usually it present in many sources like fossil fuels, dust, smoke, fog, etc. It can build up in a respiratory system and aggravates heart and lung diseases, increases risk of respiratory infection. So what are the sources of this particulate matter? See, the tiny particle means how it looks. The size of a particle, particulate matter is particulate matter. Here you can see this size is particulate matter is 10 mm and this particulate matter is 2.5 mm, 2 or 2.5 mm. The human hair is of size is 70 mm diameter, but particulate matter size is less than this. You can consider, you can imagine just the dust particle or the size. Based on this size, this also acts as a pollutant. This particulate matter, the size of the particle is very tiny, very size is very less. It is in micrometer range, and this particulate matter produced during combustion as a secondary products in atmosphere that might shift very long periods far from their point of source. And this particulate matter, how it is the chemical composition, what are its chemical composition is, it consists of soot, hydrocarbons, ash, metals, metals like vanadium, nickel, zinc, sulfur and nitrate compounds. And it also contains, the size of the particles is deeply, it can very tiny particle, so that it can deeply penetrate into the human respiratory system. Because of this, it can damage human respiratory system, this particulate matter. So when you consider the ash, you can see the graph pictorial representation or a graphical representation of a particulate matter pollutant, how it destroys. Say 0.1% sulfur, based on the sulfur, 0.1%, here 0.5%, 1.1%, 2%, 2.1%, 2.8%, 2.9%. Ash is nothing but it significantly reduces the lower sulfur oils. soot and sulfates are directly depends on the sulfur content. So why sulfur is very important? See the color of this is the ash, this one blue color is water associated with sulfate, and orange color is sulfate SO4, and another blue color gray color is elemental carbon, and organic material is green color. So this all contains a sulfur, mainly based on the sulfate or based on the sulfur size. We can decide the what type of particulate matter and how it deposit on the surface of a atmosphere, how it is acting as a pollutant in the atmosphere. So what are its effects? It effects is atmospheric dust causes allergic and respiratory diseases. It can cause a smoke cancer, causes cancer, coughing, nose blocking, and heavy breathing. A particulate affect the children's brain. Lead or a lead, if it contains lead, it affects the children's brain system, and because of its smaller size causes damages in the lung tissue. The acids and aldehyde particulate causes eye noise and eye nose, this is not noise, eye nose, spelling mistake, and throat irritation, and the plant absorption of carbon dioxide is restricted, and deposition of toxic metal on soil make is unsuitable for plant growth. So these are the effects. Because of particulate matter increases in the atmosphere, it affects the respiratory system. Because of that you can get cancer, cough, nose blocking, and heavy breathing. Especially children's brain get affected because it is because of the size of the particle, and also it damages the lung tissue, and it causes irritation in the eye, nose, and throat, and it can absorb the carbon dioxide, and which can restrict the plant to grow. So not only in the human system, for the plants also it affects the particulate matter. How we can control this particulate matter? This particulate matter can control based on the density, thickness, and the electrical property. The particulate matter, some of the techniques, what are the techniques it is used to remove this particulate matter is use of sustainable fuels which do not produce much smoke like coke, but maintaining fuel air ratio, equally maintaining the fuel air ratio, you can control the particulate matter absorption, or sufficient mixing of air and fuel, or maintain sufficient ignition temperature, providing sufficient space permit to the time for the proper burning. So because of all these control on smoke, because of all these measures if you take properly, we can have a control on the particulate matter on the atmosphere as a pollutant in the atmosphere. This is about particulate matter. So particulate matter, the sources and the controlling measures and its effects. It will be asked for 7 marks in your exam. Clear? And one way of removing is, I will show you the gravity settling chamber. This gravity settling chamber, because it is very tiny size particle, from one size a dirty gas is passed into the chamber, and here you can see a funnel type of settlers or a dust hoppers, you can say dust hoppers, where it can collect all the dust particles or particulate matter. Because of the gravity and size of the particle, all the particles settles here in the middle portion, and which is being sucked by these dust hoppers, and the clean gas is liberated from the outlet. So this type of instrument, if you use as adopting gravity, this is called as gravity settling chambers. You can deposit the particulate matters, or you can collect it, the dust particles easily you can remove in from the atmosphere. This is one way of cleaning the gas. Okay. And next way is wet scrubbers. What are wet scrubbers is, the simplest type of wet scrubber is, here you can see wet scrubber. I'll show you. This is a wet scrubber. When particulate gas is passed into the chamber, it comes in contact with the water spray. See, I'll show you. See here, this is one chamber. which contains the water spray, like water. If you spray the water, because of tiny size of the particulate matter, what happens, it get absorbed on the surface, it get wet by the water vapors, then it can be easily settled and it can be easily captured. You can see here, this is a layer of water, this is a water where we can spray, you are spraying the water here the spraying. So once the dirty gas is passed from here, it contains a particulate matter. Because of water, it get wet, and once the get wet particulate matter, it gets settles, because the water droplets capture all the wet particulate matter, and at the bottom of the chamber settle down here, and the bottom of the chamber it gets settles here, at it gets settled, and easily it can be removed. This is one way of removing particulate matter. This is wet scrubber method. Fabric filter is, and particulate matter is filtered by passing through fabric. See, fabric is the cloth piece, fabric filters, which acts as a filter. It has to be here in this chamber, you can see fabric cloth pieces or a fabric absorbents are fixed here as a layers. Once the dirty gas is passed from the inlet, all the particulate matter, because it captures by these fabric filters, and the remove, and then it can be removed, taken out, and the clean gas can be produced. And this is one way of fabric filter. There are three ways. One is gravity settling chamber, wet scrubber method, and fabric filter method. These are the three methods you can control, or you can remove this particulate matter into the atmosphere. This is about particulate matter. Any doubt here in the particulate matter? Am I clear? Shall I go to the next pollutant? Mercury pollutant. Mercury pollutant is naturally occurring element. It exists in three forms. One form is methyl mercury, another form is elemental mercury, another form is mercury, just as a mercury. In the three forms it exists in the nature. It exists. So what are the sources? The sources is, naturally the mercury include from volcanoes, natural mercury deposits released from the ocean. From the ocean also mercury can be released. Man-made sources include coal combustion, waste incineration, metal processing industries, from industries, and like paper industry, chemical industry, print manufacturing units, etc. And from mercury containing products such as batteries, thermometers, lamps, cosmetics, and pharmaceuticals. These are the main sources of mercury. And what are its effects? The elemental and methyl mercury are toxic to the central nervous system. The inhalation of mercury vapors causes damages in the brain, heart, and kidneys, and it causes minimata disease. Inorganic salts like mercury causes corrosive to the skin, eyes, and gastrointestinal tract. These are the effects. How we can have a control? The promote use of clean energy sources that do not burn coal, eliminate mercury mining and use mercury in the gold extraction by using sufficient absorption, and to minimize mercury in the industrial effluent, recovery and reuse mercury compounds in industrial waste, using alternative materials, replacing mercury in the electronic switches, replacing CFLs with LED lamps. Mercury emission is controlled at the source by using fabric filters and wet scrubber method. We can have a control on these type of if you adopt all these procedures, you can have a control on the deposition of mercury as a pollutant in the atmosphere. The next pollutant is lead. If you have any doubt, you should ask. You can interrupt me and you can ask. Otherwise, I'll be going the next pollutant very fast. You have any doubt? Students? All are sleeping. Students, hello.
No, ma'am,
Yes.
no doubt.
At least respond, no? If you don't respond, how will I know that you are? See, all these are just sources, effects, and controlling method. If you read the notes, it will be very clear. Anything they ask, they will ask direct questions only. Write a note on sources, effects, and controlling methods of lead pollutant, mercury pollutant, like that only they will ask. Whatever they ask, you have to write all these are air pollutants, see the effects and sources and controlling method, and you can write. It will be asked for 7 marks or 6 marks questions. Each pollutant will be asked for 7 marks. Understood? So the next pollutant is lead. Lead is automobile exhaust. How it liberates? It liberates from automobile exhaust. Um, gases, combustion of lead containing oil from lead mining and lead smelting work, and lead batteries, lead points from burning of waste oil used as an additive to petrol. High concentration of lead inhibits the production of hemoglobin in human beings. These are the effects, and it causes anemia, kidney dysfunctioning and permanent brain damage. The oxygen carrying capacity of the blood decreases, and also it causes neurological and cardiovascular effect in children. Decrease in growth and reproductive rates in the plants and animals. Both it affects reproduction, it affects both in plants and animals. How we can control? The replacement of conventional lead based products by lead free products. See, if you don't use lead free products, you can easily control the liberation of lead. And elimination of lead contaminant in drinking water by process such as reverse osmosis. If you adopt this reverse osmosis method, distillation and filtration using carbon filters, you can easily remove the lead. And by minimizing plant absorption of lead content in agricultural soil, by minimize using lead by using unleaded absorption, unleaded agricultural soils, unleaded petrols, all those things, you can avoid liberation of lead into the atmosphere as a pollutant. So the main sources are automobiles, from the automobile, from mining, batteries, and from the burning waste oil. This is about lead. When it comes to the secondary air pollutants, see, up to the primary air pollutants lead, it is there for your second IA. Clear? So this up to here you have to read for second IA. Is that clear to everyone? So what are the second IA portions? Metal finishing chapter, which we have not given covered under first IA. After that, metal finishing. Next, metal finishing you should read. Next, corrosion chapter, full third, not corrosion, third module, fuels, chemical fuels, third module completely. And this fourth module up to primary air pollutants means up to lead you have to read completely for second IA portions. Is that clear to everyone? So the next is secondary air pollutants. Secondary air pollutants are not, see, as its name signifies that they are not directly liberated into the atmosphere as a pollutants. They are derived from the primary pollutant. They are derived from primary pollutants. And these primary pollutants are, when it react with the atmosphere, the secondary air pollutants are released. Example, what are the secondary air pollutants? Example, ozone, which is not direct pollutant. Nitric acid is not a direct pollutant. Sulfuric acid is not a direct pollutant. They are all derived from the primary pollutants when it react with the atmosphere. First we will see ozone. Ozone is a triatomic oxygen molecule. It forms a protective layer at the stratosphere which absorbs potentially harmful UV radiations from the sun. What do you know about the ozone? Can anyone tell? Any idea about the ozone?
Ma'am, ozone is O3 now, ma'am.
Hmm?
Ozone.
You are
It is
not
a layer
clear.
which protects us from UV rays, ma'am.
Yes, it is a layer which protects from the UV rays. That is what we are going to see here, how this ozone is produced in the atmosphere from the in the atmosphere. See, as a pollutant, how it forms. It is a protective layer. It is a protective layer, and it protects the earth from the UV radiations which developed from the sun. Correct. So this how it forms when when oxygen, from the oxygen only the ozone will form, right? So in the stratosphere, ozone is formed from oxygen by natural process. It will form when oxygen absorbs UV radiations below 240 nanometers. At below 240 nanometers, it one second. See, when this radiation below 240 nanometers, you can see the photo dissociates into, this is called as photo dissociation, into two reactive oxygen atoms. These are all two reactive oxygen atoms. These are atomic oxygen, two oxygen atoms. So this oxygen, when photodissociation, it undergoes photodissociation naturally, it gives two atomic oxygen. So this reactive oxygens, again when it combines with the oxygen, that is O2, it gives ozone, that is O3. It gives ozone, that is O3 it gives. This ozone itself absorbs UV radiations in the range of, see, this ozone itself absorbs UV radiation in the range of 200 to 300 nanometers. It releases oxygen into the atmosphere. See, once the ozone liberates into the atmosphere, it forms as a layer in the atmosphere. It itself starts absorbing the UV radiation, and it gets dissociates to give oxygen, that is oxygen and oxygen atoms, that is just O. Not only O2 it liberates only into atomic oxygen. And this, however, when it released into the atmosphere, again it recombine, again these two, again it recombine to give ozone. This is the process. First oxygen, it undergo photodissociation to give to give atomic oxygen. So this atomic oxygen reacts with again oxygen to give ozone, and this ozone again it under absorbs UV radiation and to give oxygen, that is O2 and atomic oxygen. Again it recombines to give ozone. This is one cycle from oxygen to oxygen. Understood? This is how ozone will form in the stratosphere as a layer. So when you look at the ozone here, it is it is a triatomic oxygen molecule, and this protect the layer from the stratosphere, and potentially, which is potentially harmful UV radiation, it is been protected. And this formed from the car power and chemical plant exhaust. Usually from the chemical plant exhaust and automobiles and power plants, this ozone layer get depleted. And what are its causes? It causes, or it affects the respiratory system. It increases the asthma, in the lung function, and inflammation and damaging the lining of the lungs can be caused during the ozone depletion. How it will form this? We have seen the formation of ozone in the stratosphere. In detail we have seen here. It liberates ozone to oxygen, from oxygen to atomic oxygen to ozone. So the next, it causes. What is the cause of ozone depletion? The cause is naturally because of CFC. CFCs is chlorofluorocarbons. Increase in the level of chlorofluorocarbons decreases the oxygen. How it depletion takes place? See, CFCs is chlorofluorocarbons. CF2Cl is the formula for CFC is chlorofluorocarbon. CF2Cl2. When it undergoes free radical reaction, it is a free radical reaction and highly volatile compounds. Chlorofluorocarbons are highly volatile. It gets dissociates to give chlorofluoro CF2Cl and a radical, free radical of Cl radical. So this Cl free radical has a free atom. Here it react with the ozone, combine with the ozone, and usually it degrade. Catalysis takes place here, and this ozone layer in the atmosphere, as soon as this Cl radical released into the atmosphere, react with ozone to give CLO. See here, ozone get depleted to give CLO free radical and oxygen it get liberated. So once the oxygen get liberated and this CLO free radical, which is inactive state, again it react with the oxygen to give Cl radical and the ozone, Cl radical and the oxygen, Cl radical and Cl free radical and oxygen. So this is how slowly, completely, whatever the ozone is present in the stratosphere, by increasing the concentration of CFCs, chlorofluorocarbons, into the atmosphere, it combines with the free radical. All the ozone molecules combines to give oxygen. So this is how the combining effect, this is how ozone get depleted to give molecular oxygen and atomic oxygen. So the free chlorine atoms again react with ozone and the process continues and this results in the depletion of ozone layer. This is how the ozone layer get depleted by increase in the portion of, that is CFCs, that is chlorofluorocarbon content in the atmosphere. So what are the effects if it get depleted? If there is no ozone layer, what is the effect? It affects the skin, high damage, it causes immune system damage, accelerated aging of the skin, and decrease in the crop yield. So these are the effects caused by the ozone depletion. So the next, ozone depletion can be controlled by alternatives. You find an alternatives for CFCs. CFCs is nothing but chlorofluorocarbons. What are the alternatives such as HCFC and HAV? Hydrocarbons, fluorocarbons, hydrofluoro associates or atoms, and control the release of ozone depleting substances into the atmosphere and encourage the growth of plant. If more and more plants are grown, then it produces oxygen and stop deforestation. And if you stop deforestation, easily ozone, we can protect the ozone layer into the in the atmosphere. This is how we can control ozone layer depletion in the atmosphere. So the next pollutant is waste management. Next, this is about the first primary pollutants and secondary pollutants, mainly about ozone and ozone depletion. This completes one chapter and the next chapter is waste management. This we will see in the next class. So for your second IA you have, for second IA, you have this complete primary and secondary air pollutant up to ozone. You read and come. So from first chapter in the fourth module, waste management will be given in the third chapter, third IA. Okay. Any doubt in the ozone formation and ozone depletion?
No, ma'am.
Many are not attending the class. Why? If attendance shortage is there, how you will get the eligibility criteria? How we will get that eligibility criteria for the examination? We need to send the list to the VTU based on your attendance and IA performance. So keep that in mind. Attend the classes. Attend the classes. Clear? So we need to send, after we sending attendance and IA performance, then only you will be eligible for the exams or whatever the coming up process. Next process you are eligible only if you are, if we send attendance. Okay, if you have shortage of attendance and if your performance is very poor in attendance and IA, that is now we are not going to, we are sending the same to the VTU, then next whatever happens, then you have to suffer. Repeatedly I am telling. How many of you have not submitted the assignment yesterday? Yesterday was the last due date, no? Assignment?
Ma'am, it's today, 23rd.
23rd. Okay, still how many are to submit?